Hey everybody, and welcome to tutorial number 5 in the series for the Brooklyn College Multimedia Production students. In this tutorial, we're going to be looking at simple keyframing animation in Max and some approaches to that. In the background today, we have a painting by the wonderful Jess Frederick, who's a childhood friend of mine, and I've watched her work develop over many years, and she has a lovely style. I recommend you look her up. So let's get started with the Max. So we're going to start with our basic structure here that we've been starting with throughout the whole tutorial series, with a few additional notes that I want to make. We haven't really discussed what this second outlet of auto patter is about, and probably some of you have held your mouse over it and seen it's the exclude connection. What does that mean? Well, auto patter and patter storage store the state of every user interface object. So that's every number box, every toggle, every dial, every slider. And that's extremely useful, but also sometimes it's too much information. So the very handy exclude connection allows you to choose objects that you do not want to be recorded. So for instance, we don't want to record this master toggle because we want to be able to determine from moment to moment if our video rendering is turned on or off. Similarly, we don't want the number of the cue that's being recalled itself to be stored into a cue, because that's going to create recursive problems where, for instance, cue number 3 calls cue number 4. So cue number 3 will always move immediately to cue number 4. It's better to exclude that. And similarly here, we've just added a number box that allows us to choose which is the cue we're storing. So we want to store cue 13, we put a 13 into this number box, and as we've looked at in the previous tutorial, it formats this message box as a store button. We don't want this to be stored into the auto patter, so we also add the exclude connection to it. The other one that I've highlighted here in blue, just a useful little tool. If I am looking at cue number 3, then if I make some changes and mouse over to the store button, note the store button is already set to store number 3. So this blue connection just keeps the cue that we're looking at, or the keyframe that we're looking at, in sync with the one that we're storing. And of course we can change that if we don't want that connection to remain, because the data will only flow through this patch cord when it passes from the number box. So if I use this button, this is another addition, a button that will take me back to this cue. So it takes me back to cue 4, and you can see that 4 passes from the floating point number box into the integer number box through the store $1 message and creates a store 4 button. So whatever cue I'm on is automatically the next cue that I'm storing. So let's just build something here. What I'm building here, as always, is just an example, a very simple example for the students in my class. What I want you to do is make something very different from this. Make something from your own creative vocabulary and start using the tools that we've covered in the class creatively and in an individual way. And obviously, for all of those of you watching on YouTube, I give the same suggestion. So let's start out by just making a couple of cubes, and I've already made this code. So I'm going to paste it in. It should be familiar, but I'm going to quickly go over it with you. And as always, I like to be in Monaco font, so things are nice and mono-spaced so I can really see the spaces clearly. So what I have here is a simple cube with a jit.gl.material attached, and I'm animating it with a jit.anim.drive. I've added the @ease 0.5, meaning that any transition I do will ease in and ease out. So there'll be a smoothness to the transitions, and there's several ease functions you can choose from. I've chosen the cubic ease function because I like the way it looks when I make transitions. So these two additional attributes may be of use. And as always, if you want to learn more about the various attributes of the object, you can always hold on the Option key and click an object, and it will call up the interactive help patcher that shows you many features of the object in multiple tabs and gives you in the right column all of the various messages the object receives, all of the attributes that can be typed in, and similar objects from the See Also section. If you want even more information on an object, if you really want to know everything about it, click on the little question mark here and open the reference, and that will open up the Max documentation, which will give you a complete listing and description of every attribute and message, and every aspect of the object will be covered in the reference. And as always, with computing, there's multiple ways to do things. So if you forget the option click, you can always click on an object, go to the Help menu, and open the help file here, or open the reference. And note there are also keyboard shortcuts. Command Option H for help, Command Option R for reference on the currently selected object. So I'm using my Move To, which we're very familiar with. If I want to move it farther away in space. Here I've set aside my time and marked it in orange so that I don't get confused which is X, Y, Z in time. Time is set off a little bit here. So if I want a 5-second transition, bring me back to 0, 0, 0, it will make that transition over 5 seconds. And here I have my scaling. Where I can change the aspect of my object, and here I have rotation in X, Y, and Z. Now note, as we've covered in the tutorial before, the jit.anim.drive does not accept XYZ rotations. It accepts quaternion rotations, which are a 4-digit, not human readable format. So you do need the jit.euler to quat object to convert from your XYZ into quaternion, and then you use a pack with 5 arguments. The first 4 arguments are the factors in the quaternion that are calculated by the jit.euler to quat. The last one is the number of seconds. So if you want to do a rotation over a certain number of seconds, say 5 seconds, you can put in nice basic XYZ values, and you'll see the rotation happening over the time selected. But it is worth noting that the time goes into the pack rotate 2, while the XYZ go into a separate pack that then passes to the jit.euler.quat. So here I'm going to reset this object back to simple settings, and I'm going to also create a camera that has its own jit.anim.drive. And so if I, for instance, move that camera to 10 meters away over 5 seconds, we'll see the camera fly back to 10 meters. And then I've put a position attrui here because it's nice to be able to monitor the current state of the object. So as I fly back in, we can see the position updating here. And this is because the attrui is an unusual object in that data flows 2 ways along the patch cord. So we can control the object from the attrui, but the object also reports its position to the attrui. That is unlike a number box, or in fact most other objects in Max. That is quite unusual. And if you want to be reminded of that, feel free to color code cables that are coming from attruis just to remind you that they are 2-way connections. And I use color coding a lot in my work because it just helps me keep track of what's going on the screen, because the screen does get very complicated in Max relatively quickly. One other note, just note that I have added a low dimensionality because these are cubes. So unlike spheres that need a high dimensionality in order to be smooth, a cube does not need a high dimensionality in order to be smooth. And adding additional dimension to the cube will just cause more work for the computer and won't actually add anything to the quality of the rendering. So let's see if we can just do some simple animation on this cube, synchronizing it with music. Well, first of all, what's the structure for bringing in some music? One of the objects we can use for that is the SFPlay tilde object, and this will play a sound file. The SF stands for sound file. It's a sound file player. It takes 3 arguments. The first is the number of channels in the sound file. Most sound files we're going to work with are stereo, meaning they have left and right channels, so we put in a 2 for 2 channels. The second argument is the buffer size, which is not really important at this point. Just put in a large number. I'm putting in 12,000, which is much more than enough memory buffered to play back the sound file. Really, this argument is for if you're playing back large multi-channel files with 8 or 10 audio channels in them, which we're not doing in this case. And then the final argument is how many time outputs we have. And this is our critical argument. We need at least 1 time output in order to synchronize things with the sound file that we're playing. So SFPlay, 2 channels, 12,000 buffer size, 1 time outlet. And we then want to be able to control the volume of the sound coming out of the sound file player. So live.gain is a good object for that, live.gain tilde. And that just gives us a nice level meter and fader to control the volume of the sound. We'll take the 2 sound channels out of the SFPlay, pass them into the live.gain, and then, of course, as we've seen before, the easy DAC tilde is our sound output, and it shows an icon of a speaker. We'll take the first 2 outlets of the live.gain and pass them to the speaker. And a toggle is going to play the sound file. And this toggle, again, is not something that we want to be included in the pattern storage, so we're going to exclude it with an exclude connection. And let's just going to run that right along the top of the screen so it's out of the way. So how do we get a sound file into here that we want to play? Well, that's in a message box. We put the open message, and when we send the open message to the SFPlay, it opens up a standard file dialog from which we can choose any audio file. If you know the name of the audio file that you want to open, you can put it in quotation marks after the open. So open space quotation marks, and then the file I want to read is called 14 pretty silver stitches.m4a. And when I turn on my audio and open that file, I should be able to play it. Wonderful. And every time I turn off the toggle, the sound file will stop and rewind to 0, and every time I turn on the toggle, it starts over again from the beginning. And if you want to find out how to jump around and create cues within the SFPlay tilde object, again, option, click the object, it will open up the interactive help file, and you can learn a lot more functions of the SFPlay object. It's actually an extremely full-featured object with many tabs of information, and even more information if you go to the reference section of the help file. So the third outlet is our file position, or time elapsed. But that time elapsed, look, it's a stripy signal cable. So it's actually reporting the time as sound, as audio rate data. So we need a new object here in order to look at that information. And that is the number tilde object. Number tilde is a new kind of number box that allows us to see numerical data that's being sent at the audio rate. So as I turn this on, we'll see the time elapsed in milliseconds here in this number tilde. So an unusual thing here, and this is one of the things you're going to need to keep in mind as you use the number tilde object, is we're going to use the left inlet of the number tilde object, but the right outlet, because the right outlet converts this audio rate numerical information into our familiar floating point numbers. And so now that they're floating point, we can deal with them as we've been dealing with numbers all along. Now they're in milliseconds, which is a little bit hard to read, so I advocate dividing by 1000 floating point, and that then gives us seconds. 1 second, 2 seconds, 3 seconds, 4 seconds. We see the seconds are counting by in this number box. So then how do we define a cue or an event that we want to happen? Well, there's a little formula that uses some objects we know and a new object. So let's take a look at that. So if we want to look at a particular time, let's say 4 seconds, and if we want some event to happen at 4 seconds, we can say greater than 4. And then since the greater than is going to report a 1 if true or a 0 if false, we can use the select object to say no, the time is not greater than 4 seconds, or yes, the time is greater than 4 seconds, and that gives us two outlets, one for false and one for true. We'll put a button on each outlet and see what happens. As the time counts up towards 4 seconds, we'll see that every elapsing moment reports false. This is not greater than 4. But then when we pass the 4-second mark, now every time is greater than 4. But we don't want our event to trigger so many times. We don't want it to trigger every 100th of a second once the time is past 4, nor counting up from 0 do we want it to trigger every 100th of a second until it becomes 4. We just want to see the edge. We just want to see the transition when the time passes 4 seconds. So we have an object for that called change. And the change object will only send its output when the value coming in changes. So now we get no output until the state goes from false to true. Passing the threshold of 4 seconds, we see true reported. And when the time is no longer greater than 4, we see false reported. So watch these buttons down here. We're going from 3.4 seconds, 3.5, 6, 7, and then as soon as we cross the threshold of 4 seconds, and we're greater than 4 seconds, we get a single bang out of the middle outlet of the select object. So this change detects edge transitions, or changes in state, when the value goes from not greater than 4, which is 0, to greater than 4, which is 1. So if we plug this into our situation here, we'll see that when we start the sound, we get nothing, but when it passes the 4-second mark, we get a single bang. And then notice when I stop the sound and it rewinds to 0, we get a report that the value is has returned to 0 and therefore is no longer greater than 4. So we don't want to start with 4 seconds. We want our first event to be at 0 seconds. So we can say when the value is greater than 0, report 1 or true, and when the value is not greater than 0, report 0 or false. So we start it, and immediately we see that 1 is reported because as soon as we start, the value becomes greater than 0. And then as soon as I stop, watch, when it returns to 0, the value will no longer be greater than 0, and so we'll get the first bang. And there, that first bang is reported. Now here, I have to stop and caution you about something, because we've added these two number boxes in order to look at what's coming out of the number tilde, in order to look at what's coming out of the divide by 1000. These number boxes are user interface objects, so they are going to be recorded into our auto pattern. So that's a potential problem, and there's two ways to solve the problem. One, we can use our exclude outlet again to specifically exclude these two number boxes. But as you can imagine, this is very quickly going to make things messy. Look at these additional chords that we don't really need. What I would recommend instead is remove them if you don't need to see it. And if you do want to see it, use the right inlet of a message box, because a message box is not recorded as part of a pattern storage. So here we still get the value displayed, but when we record a new cue into the pattern storage, the value in here will not be saved. The other nice thing that this creates for us is it gives us a button that captures the last time that has been output. So if we hook up another message box here, we can trap certain times. So if I have an event and I want to find out what time that event happens, right, I clicked the message box at the moment of that change in the sound, and it reported the time, 5.49 seconds. So now I've got this record of that time that I wanted to identify, and that can be useful later on. So let's try and create two cues here. One cue for our starting position, and then a second cue that we want to happen as soon as the playback begins. So we'll set our starting position. This is actually fine as a starting position. So this is our cube is 1 meter cubic. It's at 0, 0, 0. It's unrotated, and our camera is at 2 meters away from the center of the scene. So we will just store that as Q1. And let's create some new situation for Q2. We'll put the camera 6 meters away over 5 seconds, and we will rotate the cube to 180 degrees on the x-axis, also over 5 seconds, and we'll store this as cue number 2. And now we can check these. Here's cue number 1, okay, and cue number 2. Very nice. So now we can simply use message boxes to say when the time is not greater than 0, so when the time is at 0, we'll be in Q1, and when the time is greater than 0, we'll move into cue number 2. Now, of course, these values are headed here to this box connected to the pattern storage. So what we want to do is make this connection, but again, here we're making long connections across the screen. That's messy, so it's a wonderful time to use the send and receive objects. And I always like to color code my matching sends and receives so that I can visually see how they're related to each other. And this should, I'll get into Q1, and as soon as I start playback, Q2 will be triggered. And there we are. And as soon as I stop, I'll jump back to Q1, because as soon as I untoggle this, the sound file rewinds to 0. So moving forward with this, we can define more and more cues. And as we add objects to our scene, they will automatically be added to the pattern storage. So I'm going to take my camera and move it over a bit, and I'm going to make another cube here. And in Q1, I'm going to have this cube be 0 in scale, meaning non-existent. So I'll just store this as Q1. And in Q2, I'll actually continue to have it be non-existent in Q2, but I'll add a third Q here. Which will bring my second cube into existence. At a scale of 1 by 1 by 1, rotated to 180 degrees over 5 seconds. And let's see what that looks like. And let's have this second cube be triggered at 5 seconds. So I'll say when the time is, or I can, yeah, 5 seconds is fine because this transition in the sound happens at 5.5 seconds. So that should match up nicely with the music. So at 5 seconds, and I can just repeat this structure. And now I don't care about when this condition is false. I only can care about when this condition is true. So when the time is greater than 5 seconds, then we're going to trigger Q3. And I, of course, don't need these buttons here, but these buttons will flash to show me that I'm transitioning from Q to Q. So I'm going to save this current state of affairs as 3 and watch my animation so far. I'll go back into Q1 at the beginning and begin. There's Q2, and there's Q3. And everything doesn't need to be recorded as cues in the pattern storage. For instance, I can have something different happen at 10 seconds. And it doesn't have to be a new cue. It can be, let's say I want both of my cubes then to rotate to a random Z rotation, let's say. So I'll create a random object that'll choose any degrees between 0 and 179. Hook that up to my Z rotation. I'm going to go into Q3. And here I can randomly rotate both cubes in the Z-axis. So if I want this to happen at 10 seconds, I can create another send. I'll call it random Z rotation. Make a corresponding receive here. And this is just a wireless patch cable between these two objects. And I'll give it a unique color combination. And I should, if I return to Q1, when I start this, I'll immediately be in Q2. After 5 seconds, I'll go to Q3. And after 10 seconds, I'll get a random rotation on the Z-axis. Now that's not that exciting because we can't really see the effect that that random Z rotation is having. We can make it a random Y rotation instead, which should show up a bit more interestingly. And I'll just rename this to random Y just so I'm keeping track of what I'm doing. And take a look again. Go back to Q1. Nice. And then I can continue. Let's say I want a few more of those random Y rotations. I can say, all right, I'll do another one at 15 seconds. And I can use my same send. And I'll do a third one at 20 seconds. And just to make this even a bit more visually interesting, I'm going to go into Q3 and I'll further change the rotation of this object in Q3 just for some additional visual interest. And let's see what I get. Go back to Q1 and play back. And here we are coming up on 15 seconds, and now coming up on 20 seconds. And I'm getting a nice dynamic animation that's combining elements of my cues stored in pattern storage and some random changes that happen at specific times. I'm using the command J command to shrink these down to save a little screen real estate. And let's go in another direction with this. So we can, for instance, one of the things we don't currently have is a background. So for a background, we can copy something from our previous work, for instance, a grid. So I'll just take a simple grid structure that I have prepared, which is very similar to what was covered in the last tutorial. And paste it in. And this is a grid of 100 randomly colored circles as a background. And so the way this is working, it's using the grid structure that was gone over in the last tutorial, and then there's a randomly assigned color for each of the circles. And they are at a scale of 1, 1. And so if we want these to appear at a moment in our animation, we need to start with them not being present. So we could have them default to scale 0, 0, which means they're there, but they're not visible. And then at a certain point, if we want to scale them up, we can say scale to some value over 5 seconds. And we'll see the circles grow in place. Very nice. Here, let's try even a larger scale. Very nice, interesting graphical background. So one thing to notice when you're using a two-dimensional form such as a circle and scale to. The scale to inside our poly is being sent to the jit.anim.drive, and the jit.anim.drive always sees time in the 4th location. So even though circles do not have a depth, they don't have a z-scale, we need to put some z-scale into the scale to message. And it can be 0, that's going to work just as well. But there just needs to be a placeholder there in the z dimension for the scale to work properly. So how would we trigger this to happen? Well, let's say at 25 seconds, let's say at 20 seconds, we also want these circles to appear. So we'll just send circles. And that's going to send the bang here to the receive, which will trigger this message. And again, I like to color code these so they're easily matched up. So we return them to a scale of 0 and return to queue number 1 and start our animation over again. At 5 seconds, get the first rotation, or get Q3. At 10 seconds, we get the first random rotation. 15 seconds, second random rotation. 20 seconds, third random rotation, and the circles grow. And then when I turn this off, I'm going to return to queue number 1 because this condition will be met here. But let's look at something interesting. And this will be the last thing I'll cover in this tutorial, then we'll wrap up. If I now go to Q3, my circles have not shrunk back down. Why not? Well, because I haven't told them to. Because here's my instruction right here, scale 0, 0, that returns my circles to invisibility. So I need to add another connection that says when I return to queue number 1, also reset my circles to their invisible state. So here I can use yet another send. Actually, I don't even need another send because I already have send queues. So I can use my receive queues here and another select object. So what this means is every time a new queue comes through, see if it's Q1, select 1. If it is, bang, and that will reset my circles to 0 dimensionality or invisible. And so now, if I jump back to Q1, I should be able to run the entire animation. And that's, of course, a very simple introduction to how one would start doing a keyframe-based animation in Max. But it does combine a lot of the things we've looked at already with a few new concepts. So I hope that's a useful starting place for you. And, of course, I want you to go as far as you can with this and make it look really, really different from the demonstration that I've done here so that you can explore different visual ideas and really come up with something unique and interesting to you. So thanks so much for watching, and feel free to email me with questions. And for students in my class, I actually insist that you email me with questions. I expect that you'll have some questions on this tutorial. Please don't hesitate to send me an email with your questions. Thanks so much.